Hello, in this video I'm going to be working through 3 different practice questions using the quotient rule, and I'm going to timestamp each question below so you can easily skip through to the next question if you don't like the one I'm doing. So let's bring the quotient rule down just because it might be a bit of a trickier formula than the other two. So for the first example, we need to find the derivative of e to the x plus 1 all divided by e to the x minus 1. And so in this example, my function u is the numerator, so it's going to be e to the x plus 1, and my v is the denominator, so that's e to the x minus 1. So let's calculate the derivative of u, that's just going to be e to the x, and let's calculate the derivative of v, and that's also e to the x. So now we can calculate our dy by dx, and that's given to us by the function v, so this one here, multiplied by the derivative of u. So that's going to be e to the x multiplied by e to the x minus 1. And then we're going to subtract from that the function u multiplied by the derivative of v. So that's going to be subtract e to the x multiplied by e to the x plus 1. And then we divide all of that by the function v squared. So that is this one here, squared. So that's going to be e to the x minus 1 all squared. So we could actually simplify this a little bit. We could factorize out the e to the x term on the numerator, and if we do that we would get e to the x multiplied by e to the x minus 1, and then because we've got this little negative there, this second term is going to become subtract e to the x subtract 1, and again that's going to be all divided by e to the x subtract 1 squared. So these two e to the x terms are going to cancel out, and on the numerator we'll be left with e to the x multiplied by negative 2, all divided by e to the x minus 1 squared. And so we're going to get negative 2 e to the x, all divided by e to the x minus 1 squared. And that is our derivative for the first question. Let's look at the second one, where we need to find the derivative of e to the x, all divided by 2x plus 1. And so in this example, my function u is going to be e to the x, and my function v is going to be 2x plus 1. So the derivative of u, that's just going to be e to the x, and the derivative of v, that's just going to be 2. And so now we can use the quotient rule to find dy by dx, and if we wanted to, maybe we could bring it down again. So this is the quotient rule here, I'll bring it there. So we're going to take function v and multiply it by the derivative of u, so that's going to be e to the x multiplied by 2x plus 1, and then we subtract from that the function u multiplied by the derivative of v, so subtract 2e to the x. And that's all divided by the function v squared, so that one there, so 2x plus 1 squared. So we could actually probably simplify the numerator a little bit. We could factorize out the e to the x term from the numerator, and if we do that we're left with 2x plus 1 subtract 2, all divided by 2x plus 1 all squared. And if we simplify that, well, we've got 2x plus 1 minus 2, so we're going to get e to the x multiplied by 2x minus 1, all divided by 2x plus 1 all squared. And that would be our derivative. Now this final example, we're going to take the derivative of tan x. So at the minute it's not really in a form to use the quotient rule, so we're going to have to rewrite tan as sine divided by cos. And if we do that we get y is equal to sine of x divided by cosine of x. And so now we can say that u is going to be equal to sine of x, and v is going to be equal to cosine x. So derivative of u, that's just going to be cos x, and the derivative of v, that's going to be negative sine of x. And so now we can use our quotient rule to find dy by dx. And so if you remember, that was the function v multiplied by the derivative of u, so that's going to be cos squared x, and then we subtract from that the function u multiplied by the derivative of v, so that's going to be subtract negative cos squared x, so that just becomes sine squared x rather, so plus sine squared x, and then that's all going to be divided by the function v squared, which is cosine x, so we're going to divide it all by cosine of x squared like that. Now if we look at the numerator, cos squared x plus sine squared x is actually a trig identity and it equals 1, so this derivative is going to be equal to 1 over cosine squared of x, and 1 over cos of x is secant x, and so if we're squaring it, our answer is going to be sec squared of x as our derivative. So hopefully this video was useful. If it was, subscribe, like and share, and check out my channel for tons of other maths tutorials. Thanks for watching.